So, as you already heard in the previous presentations, often and usually EPCs and renovation roadmaps, renovation passports are issued for purely energetic terms. So to understand how energy demand can be reduced, how energy can be saved through building renovation. But at the same time, we also know that renovation has a lot of different and other additional benefits, such as increasing comfort. And the question is now, how can the renovation passport, how can EPCs, how can additional indicators take into account of such additional aspects? In my presentation, I would like to highlight 3 additional indicators. As you might have understood from the previous presentations already, the big advantage of IBRO to EPC is its flexible structure. So there is this basic module for target-oriented renovation advice. And in addition to this basic module, there are some additional modules, some additional aspects that are covered. And I will pick out now 3 of them. First, the environmental quality indicator. Second, the smart readiness indicator. And third, the measured energy performance indicator. And briefly highlight how they can provide added value to the existing schemes. Starting with the indoor environmental quality indicator, this is an approach which has initially been developed in the project Extendo and is now linked to the IBRO to EPC framework. The indoor environmental quality indicator has the ambition to cover and assess any measure that may affect different aspects of comfort or air quality changes, and thus being reflected in the overall IEQ score. What are these aspects covered in the indoor environmental quality indicator? It's first indoor air quality, second thermal comfort, third lighting, and fourth acoustics. How does the IEQ indicator now consider these different aspects? Taking this example of thermal comfort, we split or describe each of these indicators by different criteria. For the thermal comfort, for example, we take the summer comfort, the winter comfort, and operational control aspects. And each of these criteria are now then described by certain parameters. In the case of winter comfort, it's underheating. In this case of summer comfort, it's overheating. In the case of operational control, thermostat, solar gains, solar shading, operable windows, and so forth. Each of the parameters serving to quantify the criteria are now impacted by several factors. So for example, underheating by the geography of the building, by the site characteristics. There might be some microclimatic issues that need to be considered. The building system characteristics, of course, the quality of the building, the building envelope, the age of construction, the heat gains, all that affects underheating or overheating, for example. And the assessor now considers these factors and comes up with an overall evaluation and quantification of, in this case, the thermal comfort. And the overall IEQ indicator is now visualized as a rating of comfort by assigning weights to each of the indicators presented before. I would also like to add that there are 2 principal procedures that can be applied. The first one is the comfort asset rating procedure for new, renovated, and non-occupied buildings. And the second, the comfort operational rating procedure based on measurements, surveys, and checklists. And of course, the asset rating procedure is cheaper, but does not fully reflect the occupant behavior and also preferences. The second indicator is the smart readiness indicator. The smart readiness rates the readiness of buildings in performing three key functionalities. First, to optimize energy efficiency and overall in-use performance. Second, to adapt their operation to the needs of the occupant. And third, to adapt to signals from the grid. The concept and methodology of the Smart Readiness Indicator has been developed in a project by VITO, commissioned by the European Commission. So we take over this principal calculation procedure, and this procedure, this method, builds basically on the assessment of assessment and quantification of diverse smart building technologies. What are now smart building technologies? They encompass a variety of interconnected systems and devices designed to enhance the efficiency, sustainability, overall functionality of buildings, and they leverage information technology, sensors, automation to optimize building operations, improve occupant experience, and reduce energy consumption. They comprise a variety of aspects such as building automation systems, Internet of Things sensors, smart lighting, HVAC automation, and many more. And again, the weighted average indicator is then visualized as a summary, as a weighted average of all these different technologies in place in a building. The newly revised DPPD also addresses the Smart Readiness Indicator and how it can be further strengthened and adapted. Third indicator that I briefly want to mention here is the Measured Energy Performance Indicator. This indicator presents the main information on the real measured consumption of the object and their standard conditions. So why is this important? When we can observe that the actual measured energy often diverges from the calculated energy demand, because there are differences in climatic conditions, and there are differences in type of use. So the idea of this measured energy performance indicator is now to take the actual measured energy consumption as a starting point and provide a correction to calculate the consumption under standard conditions of climate and use. And this is expected to provide a series of advantages: improved accuracy, augmented user acceptance, and so forth. Again, the indicator initially has been developed in Extendo and is now fed into the context of the renovation passport in the context of IB Road to EPC. So just to go one step further, this indicator considers different ways of measurements, be it bills, real measurements via smart meterings, or building energy balance based on the consumption. And then we do the correction via the size of the building unit, external weather conditions, the energy carrier and its primary energy factors, and we also foresee some optional correction for indoor thermal environmental conditions and service provisions. And again, all that is embedded into the IB Road to EPC and connected to the IB Road to EPC basic module. Thanks. This was my presentation, and looking forward to your questions if there are any and if time allows.
Thank you very much, Lukas. I indeed appreciate your punctual performance here and the information which is even more important, and the connection that you made with the integration or the understanding of the building as part of the energy system through the smart readiness indicators, and to the user response, and also the issue that we tackled before, which is the actual monitor performance of the buildings and comparison with the designed parameters. So if there are any questions to Lukas, please go ahead now. So the question that comes in through the Q&A box is, do we have such additional indicators foreseen in the EPBD? I think that Rutger covered that in the first presentation, but from your point of view, Lukas, how does the amendments in the directive strengthen the case of the expanded EPC?
I mean, for the SRI, it's quite clear. So there is a specifically dedicated article to the SRI, and basically the EPPD foresees to strengthen the SRI, and there are now testing procedures going on. And I think next year there will be a report being launched by the European Commission on these testing activities and how the SRI, let's say what are the experience with the SRI from these testing activities, and then followed by this report from the Commission, there should also be a delegated act how to make the SRI eventually obligatory for non-residential buildings, for large-scale non-residential buildings. So that's how I read the EPPD text regarding the SRI. Regarding IEQ and measured energy performance indicator, at least as far as I know and as far as I've understood the EPPD so far, they are not explicitly foreseen, but they are, let's say, mentioned indirectly in the sense of this that the EPC should come closer to the real energy performance, that there should be that we should close the gap between calculated demand and measured consumption.
Yes, thank you for this answer indeed, and also with the integration of the digital building logbooks, we are getting closer to actual information about the performance and bringing that information to the markets, because we do want more informed buyers on the market, so that the demands glean through to the construction sector itself. So we're moving to the last presentation of our workshops. Actually, it's a joint work between Joana Fernandes from the ADENE, the Portuguese Energy Agency, and my colleague Alexander Stankov, who will have a few slides towards the end. You already know Alexander, but a few words about Joana. She's an energy expert with nearly 20 years of experience in international cooperation projects in the fields of energy efficiency in buildings and renewable technologies, also focusing on energy empowerment and user behavior change, very related to the presentation that we heard from Lukas. She cooperates with ADENE since 2012, acting as project manager for several European projects, highlight where the coordination of the HARP project could be highlighted, and the role as partner in IB Road's Label 2020 and Ready for Heat. Currently, she coordinates the ADENE's technical project unit responsible for accompanying the management of ADENE's EU projects in technical areas of energy efficiency, renewables, consumers, and energy poverty, water efficiency, circular economy, and mobility. So, Joana, we are extremely happy to have you here and looking forward to your presentations.